So today I'm going to go over chapter 7a, maybe also chapter 9, okay? Because this part, I think, very much still like like a C language or Java language, okay? And then chapter 10 would start to be different. So we will spend more time on chapter 10, 11, 12, okay? We'll spend some time on chapter 10, 11, 12. And then we'll finish this C double plus 1 part. And then we'll move on to C double plus 2, okay? Roughly, I would say maybe we will finish the whole C double plus 1 maybe in the middle of the September or late September, okay? We should be able to finish this course and then we move to the next one. Okay, that's about our time frame. So your school, I think that UCL will start late September, okay? And then ASU started already, so let me know if you have issue, okay? Okay, let's get started. Today, first, we would like to talk about function and chapter 7, 8, 9, I think all related to function. So we'll go through it quickly, okay? There are not much difference between Java language and the C++ language. The only thing that you need to know that is new or different from Java for the function is C++ language similar to C language. So your A function need to be defined. Okay, need to be defined before in the main function you call the A function. Okay, you need to put it in this way. If you don't do it that way, you have to define a prototype for it and then put your main function here and then call your A function here, and then you have to define your A function later. Okay, so must have a prototype or define before your call for your function. That's what C++. That's one thing that when you use the function in C++, you need to pay attention to. Second one that you need to pay attention to is the parameter list. Now you have integer at A code or integer B code using alias or pointer or regular variable. These different code is the more different from the traditional function. Okay, so these are something that you have to look into. That's different from the C language and Java language. Okay, C language allow pointer, but C language doesn't allow alias. Okay, so let's get started for this kind of things. So first thing, let's go over the basic idea of the function. It's still used to modulate your program. Okay, so I'll go through the slices so we don't actually miss some topic. Okay, but basically, if it is already being covered by the Java language or C language, we will pass it. Okay. So function, this one, I think, okay, function code, I think you all know it. And function has a function name and argument list, and this whole thing, we call it a function signature, okay? These are the same, so we don't repeat it. So this portion, we call it header or signature or prototype. Okay, sometimes it had a different name. So prototype means the return type the function name and the parameter type. That's called prototype. And prototype sometimes also called header. So if you put a header function together in a file, we call it header file. Okay, and the header file sometimes is .h. Okay, because you C .cpp, and then you may call a definition file called .h file. That's why the file called header file. So this is a header. So it's a function prototype. Function prototype, you just need to type, and then you don't need to implement it. You just use a semicolon. Semicolon means this function had not been implemented. Okay, so this kind of prototype in Java, we call it abstract function. But Java, you need to put an abstract before the function, but here you don't. Okay, here you don't. But similar, okay, the definition is similar. Okay, this part, okay. And it can return a value or be void. Okay, if void, you return no return value. This one's still easy, so we will go through it. Okay, header file, we'll talk about it already, so this part, okay. Okay, you can put the prototype there and then main function and then your definition of the program. These need to implement the function that you have the prototype in the prototype area. So you put your square, cube, okay, and then you call it later in the main function. But you need to put your definition after the main function, okay. But usually I don't suggest that. Usually I suggest you still put your definition of program right here. Okay. After the user namespace, but okay. So this part we are fine. So sometimes if you have a CL and you want to actually make it easy, like print function, you can use a easier print function to replace it. Okay, so that's fine. Next one, we go to the argument list, and then we actually have a parameter. Now let's talk about argument list. So first one, I would still to review the so-called reference variable. Okay, reference variable. Let me create a new folder. Okay, this one, chapter 7. Okay, before get started, let's actually still review the data type. Okay. Okay, so we may declare a variable a equals 3, right? This is when we talk about it. You have a memory, you store 3 right there. Okay, that's actually the most easier way of storing data. Now, second one, you may declare alias b equals a. So when you say integer at sign and then a, that means this one means alias. So alias in English is also known as. So B also known as A, just like I may have a Chinese name, and then my name is Eric Chow. So Eric Chow also known as Yinchin Chow, okay, my Chinese name. So it's the same person, but different name, B. So B and the A share the same memory location. You store a string in there. This one we call it alias. So alias is different from the reference in it's the same as the reference in Java. Okay, and it's different from the pointer in C++ or C language. So this one is called reference or alias. It's a different name for the same variable. Okay, so A and B now share the same memory. You allow them to share the same memory. So if your B change, so let's assume that your B changed to 4, then you see out your A equals A, see out will be equals B. So these two variables now are the same. So you should get the same value. You should both get 4 because B updated, A also updated. They are the two variable is the same variable. They just have a different name. Okay, this one called alias. So far, okay. Yeah. How about Jessica? Are you okay?
Yeah.
Next one, you may have integer pointer P equals the address of A. This one called alias. This one called body. So basically, the body of P. So the object that P pointing to is an integer. This one is what this one means. So this one, the object that P pointing to is an integer. So P's value stored with A's address. So that means P store a address and it's pointing to A variable. Okay, that's what this one means. I repeat one more time. Okay, so let's do C out P equals C out body of P equals. Okay, so you see P is an address. You don't need to know what it is, but the body of P is 4. It's what you're pointing to. The A variable's content, that's actually 4 in there. Okay. Let's add one more thing. We can also see out address of A equals. You print out the A's address. You are supposed to get the same value that P has. P is holding the address of A. Okay, these two addresses are the same. Now, so what are the use? These are actually the basic data type differences. So now what will this do with the program that we want to talk about? Okay, let's look at it. So let's look into the swap function one more time. Let's assume that we want to swap two variables, and here you do have the void, okay, swap integer a and integer b, okay. Anyway, let's put it there. Let's don't call it a b, let's call it x1, okay. And here you do have integer a equals 3, integer a b equals 4. And then you do swap on a b. Okay. So here you do see out. Let's actually write a program then. No, I want to show the data. I don't want to create trouble, so don't use the function. So let's do see out a equals a. Sorry, typo. Okay, so we print out a b. And then print out a b again after swap. So after this swap, you do swap. So you do integer temp equals x equals y equals temp. Okay, so this one is rotational swap. So we write this rotational swap, and then we swap a b and we print it again. But the code does not work. You get a b equals 3434. You are not changing anything. So right here, the problem is that when you make the call 34, your 3 pass to x. So x store with 3, you pass the 4 to y, but y has a 4. Then you do swapping, so you pick up your 3 to temp. You copy actually 4 to 3, and then you copy the temp to y. So your xy swap, but your AB no change. Is that okay?
Yeah.
So this swap doesn't work. So that we know it already, and then later in C language we have a swap one. We do have integer x, integer y. Let's call it pxpy, pointer to x, pointer to y. So we use the body. Okay, so right here, let's copy this whole thing over. So we do swap, so we do body of px assigned to temp. Because px is a pointer, so px pointer, a body of px is a integer. Okay, so body of px equals to body of py. So body of py equals 10. Okay. So this one, okay, that's actually swap one. So since you want to swap, actually pass the body of the px, so px is the address. So right here, you have to use alias sign. Address sign. Okay, what happened is, so when you call, you do have a PS variable right here, right? So PS, so you have an A variable, you have a B variable, and you do have some edges right here, some edges right here. So your edges is stored in here. So this one pointed to here. Your PY also pointed to B. Okay, so you basically pass the edges of A to here, edges of B to here. Okay, so here when you do swap one, you are not swapping these two variables. No, you're swapping the body of the PX, the data the PX pointed to. So you are swapping this one and this one. So you are swapping this one, back up this one to 10. And then rewrite this one to 4. And then rewrite this one to 10. So you will swap. So far, okay?
Yeah.
Okay, so this one is a C style swap. A C style, you have to use a pointer. Now, another one, we would use alias to swap. That's before we run, let me commit it up, okay? Let me run the program first. So 3, 4, first time no swap, second one swap, 4, 3. So it swap here, okay? So that swap by using the alias work. I'm sorry, using pointer work. Now, you can write another one in C++ language. Here you don't use pointer, you use integer alias of x, integer alias y. And then right here, integer temp equals x, x equals 1, y equals temp. Okay, now this one, again, is different. So this one is called swap 2. Swap 2 is different from swap 0, again. It actually call is the same. You are call this one with A and B. It's not like swap 1, you use edges. But the way you call is actually different. Let's look at it. Okay, so right here you do have a alias X and alias Y. So you have A and B. So when you call, you make X as the alias. So you do have you do have an integer alias X equals A because you make a call to this function. So that means you create a alias variable X that share the same memory location as A. Is a different name for A now. So Y the same thing, you actually is a different name for B now. So A back up to temp. A originally has a 3, B originally X originally has a 3, Y originally have 4. It backups 3 to temp. You multiply this one to 4. You actually write this one back to here. So your XY swap, but because they are alias of AB, so AB also got swap. So swap 0, no swap. Swap 1, swap. Swap 2, swap back. So these two swap. Is okay?
Yeah.
This is the so-called the difference is you can call by value, call by reference, called by edges. This is 3 different code. It's called by value. You just pass value to it. So this one called by pointer. You pass the pointer to the function. This one you actually call by reference or alias. Okay, remember the name. And can you mix it? So some part of them value, some part of them reference, some part of them alias. Yes, you can. Okay. Here I just use a swap as an example to show you these are different. Now let's actually look at the return value. So return value, can you return a pointer? Yes, you can return a pointer. Can you return a alias? Yes, you can return an alias. So let's look at it. Okay, let's look at it. So this one is called adjacent CDP. So remember this difference thing, you have to be careful. Okay, I try to give you the idea of what it is. When you study C language or C++ language in school, you need to remember this, okay? These are very important things. I try not to make it too complicated or too difficult. I actually give you the idea of what C++ language is. So remember the main idea, okay? Especially the kind of graph that I draw, the diagram that I draw, you have to remember that, okay? Now let's look at it, have some function. So let's do different return value, okay? So this one, let's do integer x, integer x. So return x plus 1. Let's do this. Let's do integer a equals 3. Integer b equals at a. So C out. So this one actually add function is to add a value to it. So basically you have an a variable you store with 3. When you call, you copy the value of 3 to x, and then x increased by 1, so you return actually 4. So 4 got assigned back to b, so b got a 4. So this one pretty straightforward. So you got a 3 and 4 there. Oh, I misspelled it. Sorry. One more time. So you print out 3 and 4 for A and G. That's actually typical. No problem. Okay, now can we do this? Can we actually do integer pointer 8? Okay. Jessica, can you understand what this one will work? How this one will work?
Does P like point to X and then P plus plus, so then X plus plus?
So first tell me what is X.
It's like pointing to another integer that you put in.
So X is a pointer to another integer. Let's assume this one called GG, okay. For some reason, if you call GG edges. Now, after that, what will happen to P? You will copy these edges to P because P is also a pointer pointing to the same edges, right?
Yeah.
And then P increased by 1. So you should point into the next edges that GG pointed to. And then you return these edges back to the function. So what does this one really do? Increase the pointer of the variable here. Okay, so let's look at when will we use this one. Benjamin, are you okay so far?
Yeah.
So let's assume that you have a array of 1, 2, 3, 4, 5. Okay, 5 element A already been used. Let's call it data. So your data is an array, right? So now you do this, you do integer pointer next equals to add P edges of data 2. See out body of the next. So body of the next is the return value. So is the return value of the function, right? Okay, let's look at this one now. So you have to have a data. So your data have 5 value. You have 0, 1, 2, 3, 4. I'm sorry, you have 1, 2, 3, 4, 5. Let me redo it again. This is no good. So your data is right here. It's an array. You have a value of 1, 2, 3, 4, 5, right? That's your data. So now right here, your data 2's edges. Data 2 is right here. This 0, 1 to the index. Data 2's edges being passed to your add P function. So let's assume this edges is called, let's call it A3. Okay, so pass A3 to here. So X is pointing to data 2, no problem, right? So your P share the same edges. So P also pointing to data 3, A3, the 3 value. And then P increase, P pointing to the A4. And then this pointer got returned. So the next value is the same value that you get. So next term also pointing to 4. So your return value is the body of the next. You should get a value of 4. Let me use the terminal. I think this one should be fine. But somehow this compiler in the environment doesn't allow us to do it. G plus this one called edges in that CPP. Ratio edges. Oh, data is a function name. Just don't use data, just use D. I think the problem is not because of the data, not because of I have syntax error, but because data already used as a function or somewhere. I'm sorry. So this one should be fine. Let me use a run code. So return value is 4. Return value is 4. Remember that I told you you do have a data right here. Your date, I'm sorry, this is D. Okay, let me call it D. It actually is 1, 2, 3, 4, 5. You actually use the ages of B2 is index 0, 1, 2. The value is 3. So you use the ages as your X pointer. So your X pointer pointed there. Then you assign this X pointer to a new variable called P pointer. So P's body also pointed to here now. Then P increased by 1. So increased by 1, you go to here. After this P++. And then this value, after increment, return to the next pointer. So next pointer got copied the value of the P. So this pointer is a pointer pointing to the same variable right here. Is that okay so far?
Yeah. Wait, why is the parameter like not an address thing and it's like a pointer, like the asterisk?
It's a pointer type, but you store the ages. Let me repeat one more time, okay? Let me explain it one more time. Let me give you the picture first. Your question is like, let me clean it. Your question is like, why here is not alias A, but actually it's a star A, right? X, right?
Yeah.
Going back to the swap function. So why here you use a pointer, here you use alias? You have to understand this difference. So let's look at this one first, using alias. So using alias, you do, let's assume you have A and B with 3 and 4. You use alias means your X and Y is the alias of these two variables. A different name for the same memory location. This one called alias. When you say integer alias of A, you do not create a new variable, but you actually use the old variable A as the same variable for X. So far, okay?
Yeah.
And then you swap these two values, right? So this is okay. Now, let's look at the swap one. So swap one is different. You use a PX and PY. So you originally have an A and B stored with 3 and 4. When you pass, you do not pass px here, py there. Instead, you pass the edges of this one. Let's assume this is A3 and A4. So your P really holding A3 and pointing to here. Your PX, your PY holding a A4, the edges of B and it pointing to here. And then you are swapping these two values. So you're swapping the body of where PX pointing to and PY pointing to. You're swapping these two values. So this one, when you do this one, you are passing the edges. You have a function that input edges. And then the function of this one is swapping the content of these two edges. Okay? So far, okay?
Yeah.
Yeah.
Let's go back to these edges in the CPP. Go back to this one. This one, you do have an array. So the index is 0, 1, 2, 3, 4. The value is 1, 2, 3, 4, 5. This one is, if you use alias, then you means there is a variable sharing the variable. So this one really is, let's assume this is actually x. So x is actually sharing the variable. That's not what we want. You modify this variable. That's not what we want. What we want is actually we want to have a pointer to pointing to here. But next one you actually increase by 1 to pointing to the next one. So this one actually is adding the edges by 1. Which edges? The edges that you pass in. So basically you pass in the edges of D2. Then your output is the edges of D2 plus 1. That would be your D3 edges. Is that okay?
Yeah.
Yeah.
So this one is input with edges, output with edges function. Don't use a value to think about it. It actually is a processing of the edges. So in C language, C++ language is allowed to do that. But in Java, no. Java, you cannot do calculation of the edges. So right here, you got the edges of x and you advance the edges of the x to the next edges. So the next edges is not a value. So you actually you need to use a pointer to receive the return value. Where you pointing to is from here, advance to here, but this new pointer's value need to be assigned to another pointer called next. So next pointing to here. And then you need to print the body of the next. Okay? Now. Can you do this? Input an alias, return an alias. So what will happen to this one? Jessica, can you try to answer this one? What will happen to this function? What does this function really return?
Is it just like the number you put in?
Yeah, and what happened? So let's assume that here you do integer alias k, okay, equals sharing a, and then k plus and c out. I'm going slower, okay, right here. It's a little bit tricky. Okay, so here A is 3, right? We never add or swap, so A is 3. So what will happen if you do this and then your K increase? What will happen to A and B and K? Jessica, what happened to them? So originally your A is equals 3 since you declare A equals 3.
Is K like 4?
K is 4, yeah. How about A?
Wait, can I see the function again?
This one is very crucial, okay? If you understand it, you understand everything. Jessica, you think about it, okay? Let me ask Benjamin, because it's also very crucial. I need him to also understand. So, Benjamin, what happened to K now if you do this function? K we know is 4. K we know is 4.
Okay. Then you add 3.
We basically do nothing, just pass this alias and return the alias.
Okay.
Right, this one actually we do nothing, right? We just return
Yeah.
the variable.
Wait, what about add? Well, you can't see.
We are not talking about add right now. Don't confuse yourself with add.
Isn't int b equals add a?
Hmm?
Int b equals add a, line 22.
Yeah, but that's actually
Oh,
let's do it with B. A have nothing to do with it. Don't confuse yourself.
okay.
That's pass by value. Is it nothing to do with this?
Yeah. So sharing. I mean, yeah, sharing just returns.
You have to understand this one. This is easy, but you have to understand. If you don't understand, you pretty much don't understand what's alias. So what does this return of the alias really mean? Okay, let's run and get a result. I told you A become 4. So A become 4, K is also 4. And why is that? So what does this really happen? Let's look at this sharing of A. So you have this A variable as 3. So when you call the alias, you actually assign the X as the same alias variable, so X is right here. And then you return this value as the alias as well. So you go back to look at this one. So K is the alias of the variable that you return. So basically, K also got assigned to the same location and sharing the same alias. So K is also an alias of A. So this one is sharing what? Sharing alias. What does that mean? So that means let's assume that my name is Tom Cruise. I also known as Jiang Cruz.
okay.
So Tom Cruise and Jiang Cruz is the same person, right? So my naming right, I return my naming right to another variable, and this variable assign it to a new name called Henry Cruz. So this is the same person. If Henry Cruz earns $300, then Tom Cruise, John Cruise, Henry Cruz all increase by $300 because they are the same person. So this is sharing A is sharing what? Sharing the alias or sharing the left hand side value, LHS value. What is left hand side value? You do have a integer A equals 3. You have integer alias K equals A. So K increase, A also increase. Because left-hand side value is the value that you got assigned with new value. Left-hand side value means your K assigned with a new value, then your other variable also got assigned by the new value. This is called left-hand side value. Right-hand side value is your value assigned to other people. This is called right-hand side. Left-hand side value is the right to update your value. It's the left-hand side value. So your left-hand side value, so your name of your alias of the A sharing by K. So A and K now is the same variable. Is that okay?
Yeah.
A, X, and K, 3 are actually the same variable. So this one return a value. This one return a pointer. This one return a left-hand side value. Left-hand side value is your value to be updated. Is that okay? Let's try this one.
Yeah.
Let's have the integer s equals 10. Integer t equals 20. Okay, now right here that has integer get the big one. Integer alias x and integer alias y. Okay. So if s greater than y, return x, otherwise return y. Okay, so you do have s and t, and then you do another one that's integer. Large. So alias of large equal to the big of the S and T. And then large increase and then C out. Okay. So this ST has nothing to do with AK anymore. So both of you, Benjamin and Jessica, tell me what happened to S and what happened to T. What should be the result? So Jessica, what should be the result?
Is it like 10 and 21?
Why?
Because large is an alias for t because it's bigger, and then it plus.
So your S store with 10, T store with 20, right? So you compare these two values, T is bigger. T is bigger, so you return the alias right. This alias right got assigned to large. So basically, large is sharing the same variable as T. Then this alias got updated by increased by 1. So this one remain 10, this one is 21. Is that okay?
Yeah.
So this one really is returning the left-hand side value. Return your right to be updated. Return the value, the right of the variable got updated. That's called left-hand side value. Is that okay? So basically, you return some value, you cannot change the variable because you accept the value, you will get the value, you will not be able to update the variable. But sometimes we want the variable so update value after privilege or right to be assigned to another one to be updated. This is called left-hand side value. Left-hand side value got assigned to large. So large is actually sharing the same variable with T. So T large got updated, T also got updated. Okay, so if you really understand this one, you're pretty much okay in C double plus function. Is that okay?
Yeah.
So what we spend on swap and on this addressing is to tell you what happened if your variable or your pointer or your alias become the parameter, or if your value got returned or your pointer got returned or your alias got returned, what happened? Is okay? So basically you have a function, you can enter a value, you can enter a alias, you can enter with a pointer, you can also output with value or output with the alias, that's the left-hand side value. You can update the variable that you return. You can also return a address, that's pointer. It's okay?
Yeah.
The C language, C double plus, a little bit confusing is that this one we call it address, but sometimes you also call it alias. So you really have to know where you talk about. If you say alias, this one in the right-hand side, you assign it to P. This one really means address. The address of A got assigned to a pointer P. And pointer P is a pointer P because the body of this P is a integer. So P itself is a pointer. You have to understand it in the way that I interpret. Otherwise, you will feel, hey, this one really is a body of P, then why this one become an integer? No, the declaration actually tell you the body of P is a address. Is an integer, I'm sorry. So P is a pointer. P really is a pointer to a variable. So you need to assign the address of A to it. So right here is the address. But if you declare the alias in the declaration, then we read it as alias. It's not no longer the address. It's become the alias. You have to understand it by alias. Alias is a different name of another variable. That's the more tricky part. Is that okay?
Yeah.
Okay, so far we talk about different parameter type and this one called return type. Okay, now let's look at another one. Passing the function to a function. I see this one in C language, we talked about it already, okay? But let me talk about it one more time. So let's assume we have the function called square. Okay, no problem. And then we have integer cube. Okay, so one is calculating the square, one is calculating the square. And then we do have okay, so this one we have two functions, and then we pass a function to here. I'm sorry, this should be x. So you pass the function and pass the value n to the function, and you will call that function. So let's assume that you pass the square right here, and you pass n equals 2. So you will do call square of 2. So this one you should get 4. So this is pass a function into it. You don't get a value. Oh, I think I created that. It's okay?
Yeah.
So if I call cube instead of calling square, then you will get 8. Okay, and in this way, you do have a function call, but you pass a f function to here, and you got an n value to here. So this x function right now, you can pass square into there, and your n actually is 2, and then you return 4. So function can also be a core value, a parameter. Actually, function can also be the return value. So your function in C++ language, you can put in value, can put in ages, can put in pointer, can put in function. Your return also may have the value, may have the alias, may have pointer, may have a function. It's okay?
Yeah.
Yeah.
Now, let's try to understand this part. Integer, this function. So to understand the C++ rule, you have to read to the right and look back to the left. So you read to the right is a function of integer. It's a function returning integer. So far, okay?
Yeah.
So this f is what? Look to the right is a function of integer, and then f is what? Jessica, f is what?
Like a pointer to the function.
Yes. Look to the right is a function, and then so the whole thing is a function, and then you have a f is a pointer. So f is a pointer to what? F is a pointer to the function. It's okay. Overall is a function, but f is a pointer. F is a pointer to a function. So let's try another one. Let's have a integer a3. So this one, how does this different from this? So B is a integer array of 3 values, right? So what is A? A look to the right is an array of 3 values, but A is a pointer. So A is a pointer to the array of 3 values. So A actually is a pointer. A pointing to the array of 3 variable array. Is that okay?
Yeah.
So this is the way you read the C++ language's declaration. Too complicated, so that's why C language, C language, language is a little bit complicated. But the good thing about this one is that you can do processing, you can pass function into a function. So this one, we call it functional programming. It's a new paradigm. So functional programming, you process the functions. You put a function in, you get a new function out. We call it functional programming. Jessica, are you okay?
Yeah.
Now, let me ask you a question. So in C++ language, you have a function, you put another function in, you get a new function out, right? That's okay. But in math, what that is we call it? In C++, we call it functional programming. Because you pass the program into a function. You pass the function into a function and you process, get a new function. And in math, what that is whole thing being called?
I'm not really sure.
You learned it already. You just don't know. How about Benjamin? Do you know? When you pass a function into another function, you get a new function.
Yeah. Okay.
What that is means in that what that is called in math. You already learned it. I give you the hint. Both of you already learned it. You just don't know.
Like
And this is the key when you go to college. You have to really take advantage of this one.
what's it called? It's not substitution. I don't think that's
You spend 1 year on it.
math. That's fair.
At least 1 year on it. Maybe you spend 2 years. I don't know. It's called calculus. Calculus is,
Substituting that's called calculus?
yes. Function in, function out, called calculus.
Oh.
So let's assume that you have a function f function equals x squared plus 1. You do df dtx. You got what? You got 2x. So this one really you pass the derivative function. Derivative itself is a function. Let's call it differentiate.
Okay.
So you pass in f function, you get the df dx function. So let's call it f prime function. You enter this function, you output this function. That's function input and function output. Does that make sense?
Yeah.
This we call it calculus. So you hear the word in computer science, there's also lambda calculus. They are lambda function. Calculus. Lambda calculus. Meaning the same thing. Let's look at the integral. So you do have f of x equals x squared plus 1. You do have a integral of x f of x dx 0 to t. So usually you will have a plus c term if you are in indefinite integral, right? So basically your f function enter the integral. You got this actually 1/3 x cubed plus x plus the c term, right? You input a function, you output a function. That's called calculus. This is how you know, okay?
Yeah.
So you learn calculus, you pretty much trying to understand what is the relationship of the differential function and the integral function. And we do functional programming, not only differential and integral, you also would have the map function, filter function, apply function. These are typical functional programming functions. Reduce function. But we'll teach you later when we go to the functional programming of C++. But remember, they are function processing function. So let's actually do functions in functional programming. So you assign variable, pass argument to other function, and other argument can pass as a function in the other function. This one is called higher order function. Okay, and it's a feature in functional programming. So this is called functional programming paradigm. And why we love this functional programming paradigm so much, it involves the integral it involves the recursion. It involves everything that actually you process a function and return another function. Okay, and you involve parallelism, and all of these working on the calculus and also differentiation and also integral. And the differential and integral is the key in the optimization problem. Optimization problem. You always do optimization in integral problem, differentiate problem. And this optimization problem is also the key for AI. Is that okay?
Yeah.
I'm trying to teach you why this is important. Right now, I'm not teaching you AI so far, but you have to learn this before you can go to AI. So what I'm trying to say is passing the function as a parameter is the key for the functional programming, and functional programming is the key for calculus, and calculus is the core for the optimization problem, and optimization problem is the main problem for AI. Okay, that's what I'm saying. Jessica, you hear me?
Yeah.
That just means that in your college days, you may learn all of these. You go to calculus course, don't think that, oh, this calculus course is nothing to do with my AI. I don't like it. Oh, you learn C double plus, oh, C double plus nothing to do with my AI. I just want to use the Python because people already write the library for me. I don't want to write my code using C double plus language because it's not related to AI. Then you are totally wrong. You are totally wrong because C double plus, calculus, if you put them together in the correct way, you do able to learn the top AI programs. So in fact, if you go to say Amazon, so you type C double plus machine learning. Oh, you can find many C double plus hand-on machine learning with C double plus. Okay, there are quite many books on C double plus for machine learning. Is that okay?
Yeah.
That's why in modern day, we still encourage students to learn C double plus, practical C double plus machine learning. And in here, you deal with functional programming every day. You pass a function into there, multiply the function, return another function. So what we today really tell you is you pass the value, you can return. You pass the address, you update the address, you can return. You pass the alias, you can also return the alias. The left-hand side update value, you can also return. You can also pass the function and then return a function. Is that okay?
Yeah.
And when we pass a function and return a function, we call it calculus. This is what I want you to remember. Okay. As for how to do it and which application you can use it, there are tons of things that you still need to learn. Okay. That's what I need to tell you. It's your 4-year college days. You have to really understand how to use AI. Right here, I'm just leading you into the door. After that, you have to search for yourself in the solution space, okay? But keep in mind the key idea I told you, okay? That's my purpose. Just to let you know what you can do with C++ language. Okay, as for how to apply them into calculus, statistics, physics, AI, machine learning, that's your 4-year study in college, okay? Jessica, do you hear me?
Yeah.
And why do you need to learn all of these?
Because they're all used in AI.
And then, so Jessica, and then you learn AI, and then so what? and then you want to get a job, right?
Yeah.
So Benjamin, do you hear me?
Yeah.
Optimally is to help you to get a job, to be able to earn decent salary. Okay. So here we do. Okay, there are a few examples, but all very simple now. So we don't go over this past by reference past whatever we already covered it. So this chapter pretty much it. Okay, the driver is the tester program, so it's okay. Precondition, postcondition, I think you know. So this chapter I think we are done. Chapter 8 is also, I think all you know, so not much problem. Let's go through the slices. So today I already finished the key idea I want to teach in this part, okay? So let's go to the chapter 8. My job is to help you to understand C++ faster. But you do need to practice the problem, the homework, or you have time, you work on the W3 sources, okay? Jessica, do you know the W3 sources?
Yeah.
You have to do program there, okay? Initially, you may work more problem, and then you can skip by 2 or skip by 3, okay? Every 3 problem you do one, because there are too many problems, okay? Benjamin, hear me?
Yeah.
You cannot finish everything, so you have to skip by 2, or even to skip by 5. But you do need to have enough practice. Just use it like a coding bank. Okay, but you do need to pick up chapter 1, chapter 2, and all the similar chapter because you don't want to fall behind your class in ASU, okay? So your practice need to be up to date or before or ahead of your school's schedule, okay?
Yeah.
And then Jessica, you same thing. Right now, you need to practice your Python for ICS 32 or 31, okay? But later you go into 45 and 46, then you need to practice. At this moment, you try to do C+++1. But very soon, when you take the 45, you will need the 2 and 3. 46, you need level 3. So you have 1 year to work on Python and C++. You have to use your time right, okay? So continue to the two practice. Next one is a local and global variable. I think this one we already talked about it. The static variable and the external variable. A local variable. I think this one okay, not much to add. One thing is the namespace. Namespace really means module in Python. So when you see in Python, you do have X, Y. Okay, but if there's another program also have the X, Y, then these two X, Y, if you do import, then this X, Y and this A, Y will have collision. You update this one also got affected. So because we want to be careful about it, so we always use the namespace. So we use the namespace, we will say this one is actually in Python, you have to call it like numpy array, right? Sometimes we call it np.linear space. So this one is the domain name. Here you also have the domain name. So right now our domain name is std. So last time I told you std : endo. So you can write in this way, std : endo, or just write in endo. If you write the endo, then you have to use the std namespace. If you do not have this line namespace std, then you have to use std : endo. Is that okay?
Yeah.
To tell people which endo you talk about. And when you merge two programs, then the domain may merge together. Then you have to be careful. do we have the same variable name or not? So for example, like before a moment ago, I tried to use the word data, but look like the data already being occupied by some other variable in STD domain. Then this is not a keyword that I can use. Okay. As for why, I'm not sure why they need to use the data, but I just need to avoid it. Okay. Okay, so C-level class called namespace, modular called module, Ada called package, Java also called package. This one is the namespace. Okay, Java. So Java's util is a namespace, but it called package. Okay, remember that util is a namespace. So if you understand it, this is not really hard. You can create a new namespace. Okay, but this one usually is a system engineer's job. Engineer very few would do it. So when you call it CR, you can also use STD, but in Java, it's actually using dot for domain specifier. Right here, you use a colon, two colon as the domain specifier. Okay, that's all you need to know. So your ABS function really is STD colon ABS. But you can use it, if you using it, then you actually don't need to use STD. Or you use this one. So this is just like import ABS. This one is more like from STD import star. So everything under STD will be imported. This one only importing the ABS. Is that okay?
Yeah.
Jessica, are you okay?
Yeah.
This not too hard, but I just skim over. Okay, just go over it. Other than that, I don't want to spend too much time. Binding should be fine. Binding, we spend a lot of time to talk about binding. So your storage class, you have register, auto, external, and static. Okay, now I talked about this before. Let's review one more time. Let me have Jessica to tell me what is static, what is auto, what is external, what is register. So this different one, you can have a static integer. You can have an auto integer. You can have an external integer. You can have a register integer. But what that this really means? So let's start with static integer. Can you talk about it?
Is it just like shared by the class?
Yeah, it actually static. So it will be put into the data section. No, it's not shared by the class. This one is more like private. Only the same module will see. How about external?
I kind of forgot.
External, the public is shared. Static is private, is the same package. Is that okay?
Yeah.
How about auto?
Is it like it can be any type or something?
Yeah, but where will the variable be stored? So it's a little bit like a JavaScript bar. It actually have to be stored in the code step, in the step that you call. Okay, local variable. This one and this one in the data segment. So you have a global area to store those variables. And this auto is in the step, it's local in the code step. Okay, you have to understand this, okay? Because in your ICS 51, the assembly, you will need to know about this. How about register? So Benjamin, what is a register variable? When you declare register variable,
Declare register.
Mhm. So this different name just saying that it's a storage class means that they store in different location.
Oh,
Okay.
yeah.
So when you say register, where will the variable be stored?
I guess just
It is stored in register. That's why it's called register. But where is register?
where's register?
So Jessica, where is register?
I'm not really sure.
Register is in CPU.
Oh,
So you do have a memory bank, DRAM. Okay. You have memory bank, you have a CPU. So when you say external or auto or static, this one, and this one, this is three all in DRAM, but register is in the CPU. So who is the fastest one? Register variable is the fastest one because it's just right in the CPU. You do not need to go to another IC chip to get the data. So this one usually people don't use it, but because that it actually is faster. But register usually CPU have a limitation of the number of the CPU. They may have 32 CPU register, may have 256 CPU register, but there is a total amount of register you cannot pass it. Is okay?
yeah.
So you cannot declare 200 or 300, 400, 1000 register available. That's not possible because your register is limited size. Okay, your DRAM is bigger, but your DRAM is slower. So these storage classes just tell you where your data will be stored and how it will be stored. That's called storage classes. Okay, and in Java, they do, but they don't have the register available. Java don't have auto. In the Java 8, they don't have auto. Right now, in there, auto, yes. Java already accept var. Is okay? Newer
Yeah.
version, Java 20 already accept var. Jessica, is okay?
Yeah.
So var is like very versatile. You can assign any value to it. But that's only for local variable, okay? So these two charts, the memory map, you must understand, okay? Try to understand it. So your static data, your static will be here. Your constants like string 1, 2, 3 will be stored in literal. Your external will be also stored in data. Your auto will be stored here. Okay. Your local variable will also be stored here. Anything you use new will be stored in the heap. Okay, these are something you need to understand. Okay. Everything you use new will be stored in dynamic heap. And then there's another CPU register using the register type, but right here we don't show it. We only show the main memory part. But this chart, you have to remember that, okay? Okay, other than that, you can compare everything else. We don't go deeper. So there is a register file, register variable, okay, and then how they got operating. When you have static, you go to, when you have static, where do you go? You go to the heap. No, it's not heap. Okay, the class equal to heap. Okay, class for sure equal to this object equal to heap. So this one you should okay, at this moment you also go to heap because it's local to the function. And then you may have the register variable go to register. You may have a variable go to stack. Okay, these are memory locations. Okay, we don't waste too much time on there. This scope I think is fine. So if you have a function, you put an integer x, then this one is input only. You can only input it, okay? And then if you have integer alias a, then this one you can update the value. You can also get the value, assign the value to other one. So we call it incoming and outgoing variable. It's okay?
Yeah.
So when you pass the reference, it's incoming and outgoing variable. We talk about this in C language already, okay? But it's okay so far. Other than that, I think it's okay. This function and the domain name should be fine. I don't want to waste a lot of time on these different examples. Let's see. We are almost there. Let's finish this chapter first. We are almost done with this chapter. We will move on to the next chapter to see how much they have, okay? And then the final one is talk about a bigger project. Okay, we won't go into here, it's waste a lot of time. So you can download the code to run it, okay? I don't go into there. So this chapter is also done. Let's look at chapter 9, see how much it has. We may go into there, we may not, okay? Because we already almost done. Okay. Okay, go back to the simple data type. Okay, so let's do this one and the complicated data type, the structure, and this primitive data type next time. Okay. Any
Okay.
question?
No.
Okay, so both of you will start your college soon. Okay, we wish both of you good luck. But
Okay.
if you have problem getting to the come to the class, you need to let me know in advance. Okay. And
Okay.
if you do have problem in your college study, also let me know. Okay.
Okay.
Jessica, hear me?
Yeah.
Okay. Whatever. Or if you cannot continue the class, let me know. Okay. Just remember that my purpose is to help you to get focus in CS, right? That's our purpose, and also be able to graduate in timely fashion and also get a good job. Okay, that's the whole purpose that we are doing this. Okay, good night then. Bye bye.
All right. Good night. Bye
Thank
bye.
you. Bye bye.
Bye.